Hey everyone, it's Mr. Eisens here. We're going to talk about plate tectonics and we're going to review this material from sixth grade. Hopefully, you remember a little bit of it. So, this should go quick. All right. So, plate tectonics, what is it? Where are we going with it? Why do we care? All right. We care because we live on planet Earth, and the way that planet Earth works is things are shifting around quite a bit. And so, we're going to talk about plate tectonics, what happens when those plates come in contact with each other and they shift. Okay, what happens at fault lines? What happens at plate boundary lines? All these different things we're going to review and go over today. So let's go to our KWL. What I know, what I want to know, and what I learned. What you guys are going to do is type in here exactly what you want to know and what you know. All right. And then what I learned, you're going to come back at the very end of the lesson. So make sure that you get that done. Each of you should have this slideshow. Otherwise, make sure to send your teacher, if it's me, an email or a Schoology message so that you can get this Google slide so you can work through it yourself. All right. I'm going to be going through the slide myself. You guys can follow along, pause the video, have like 2 tabs open, and work through this. Otherwise, if you don't think you need me, you can fast forward and kind of check your work as you go. All right, let's get into it. So questions. All right, drag the green boxes to answer the questions. So all you're going to do is click on these and drag them around. So what are plate tectonics? Why do the plates move? And what is the area called when these plates meet? So let's quickly answer what happens when they meet. Well, it is a plate boundary. Okay, 2 plates are meeting. Plate boundaries. All right. Let's see. Let's do this one. Floating on Earth's mantle in a process known as convection currents. All right. That's going to wind up being why the plates move. Okay. Let's see. Movement causes things like volcanoes, earthquakes, and tsunamis. This is going to be, honestly, I would put this right in the middle, you guys. I would take credit for either one because this happens because the plates move, but also this happens around plate boundary lines. So I'd put that right in the middle. A theory explains how crustal plates move about the surface of the Earth. Okay, that would be our plate tectonics. There we go. Kind of what it is. Convection currents constantly shifting. This is why they move again. And then let's see, bump together and move a couple of centimeters each year. So again, this is going to be having to do with what is plate tectonics. You could, I mean, honestly, this one goes for all of them. They're all related. I wouldn't care too much where you put this one because I think it could fit in every single one. All right. All right, let's keep moving. So plate tectonics basically is just going to be the Earth is made up of certain plates. They're going to move around, bump into each other. Some are made of continental plates, some are made of ocean plates, and let's kind of find out exactly what happens when they interact. Okay, so the lithosphere and the asthenosphere. All right, don't worry, we're not going to grade you on how you can pronounce those, but we do want you to be able to identify them. So first off, the crust is going to be on the top, then it's going to be the lithosphere, and then it's going to be the asthenosphere. So the crust, so we have 2 different types of crust. We have one that is going to be the ocean crust. Put that there. We're going to have the continental crust, which is going to be the land, or where we are right now. We're right next to the ocean crust, right? Because Houston's only an hour away from the ocean. And then we're going to have our lithosphere. It's going to be this first layer, kind of the in-between between the mantle. All right, the last part of the crust, and then the asthenosphere is going to be the beginning of our mantle. We're going to talk a little bit more about all these different parts, but make sure you get this down. Let's keep on going. So plate tectonics, let's jump into it. So we got at different boundaries, so when these plates meet, all right, different things are going to happen. All right, they're either going to be divergent, so they're going to go away from each other. Okay, divergent, going away. Convergent, meaning they're coming toward one another. all right? Or they're going to be transformed. So they're right next to each other, and they're just going to go back and forth, okay? They're not going away from each other. They're not coming toward each other. They're sliding right next to each other. All right, so keep that in mind. That's going to help you answer these questions. So divergent, plates that are moving apart, that would qualify as divergent. Form the Himalayan mountain range, that's going to be convergent because they're coming together, they're colliding, and they're creating mountains. All right, they're creating mountains, they're getting much, much higher. All right, the crust is being forced up. You can do this, and we will show you, like with a candy bar. We had a lab that we were going to do where you break the candy bar in half and then you push it back together, and you can see how a mountain forms just like it does on Earth. All right, just on a smaller scale. Most of these plates found in the ocean floor. Okay, so this is actually going to be divergent, and this is where new crust is created. Okay, we call it a mid-ocean ridge. And let's just keep on going. So can cause earthquakes. All of these can cause earthquakes, but transform is the most common. You see that in the San Andreas Fault in California. That is a transform fault where it's sliding back and forth. And so an earthquake happens when there's just a quick shift, boom, now there's a rippling effect in the ground, which causes an earthquake. Okay, created the Mid-Atlantic Ridge. Okay, that's going to be divergent, two ocean plates splitting apart, and as they split apart, new crust is formed. Okay, it's coming up from the mantle, that molten lava creating new crust on the ocean floor, and the ocean plates are breaking apart and moving to the side. Okay, so again, we just talked about new crust being formed. All right, that's going to be divergent. When these plates come together, they form mountains. So again, we got two mountain ones, convergent, they're coming together. Two continental ones come together, and they form a mountain. You could have the same thing happen with ocean plates forming an underwater mountain as well. Plates that collide, convergent, they're converging on each other, they're going to collide. So they both start with C. Plates that move side by side, again, that's going to be transformed because they're sliding back and forth. Nice work, everybody. Let's keep on going. So here, you're just supposed to drag your star to where you live. We live in North America. Okay, so we are the North American plate. You can try to get it right where Texas is if you can, but it's pretty tough. All right, let's keep on going. We were just talking about these, our transform plate, convergent and divergent plate. So you're going to have to take these at the bottom and match them up. And transform, like we said, was sliding back and forth. So that's going to be the middle one, sliding back and forth. Our convergent is when you're going right toward one another. Boom, put that there because they're headed right toward each other. Boom, creating mountains usually. And then divergent is where new crust is formed because it's splitting away, and you need to have a new crust in the middle forming that. Okay, let's keep on going. You guys are doing great, by the way. All right, so the lithosphere, we're going to see what exactly happens at each of these plate boundaries. And so when we're looking at convergent plates, they are coming together and they are colliding with one another. All right, remember divergence going away and transform is sliding. So transform, the sliding, nothing is going to be destroyed. Divergent plates, we are forming new crust. And then at these convergent plates, depending on what exactly happens, whether they collide, they're the same density, they collide and they create mountains, or we have an ocean plate with a continental plate and one subducts under the other. All right, things are going to get destroyed at that time. All right, let's keep on going. We're going to dive deeper into convergent plates. So again, they're coming toward one another. All right, which one? So we have to differentiate when we have two of the same type of plate going toward each other. And what I'm talking about is continental, or ocean, continental, or ocean, ocean. And so you can see here in our first picture here, we're looking at an ocean converging with continental plate. And so what's going to happen is the lithosphere is going to, if you can see my cursor here, the lithosphere or the ocean plate is actually denser than the continental plate, and so it's going to go underneath the continental plate. And as it goes deeper, it is really hot down there, and this plate is going to get destroyed, melted into lava. That excess lava usually is going to wind up creating a volcano on the other side. All right, so at subduction zones, we are destroying certain plates, the oldest part of the plate. But don't worry, because somewhere in the middle of this ocean, we're actually creating new plates because we are going to have a divergence. So this first one here is going to be ocean into a continental. All right, so this should be our slide right there. Now we have ocean here. Here it just depends on the ocean which one's going to subduct underneath. Usually the older the crust is, the more dense it is. And then lastly, we have our continental. Let's see if I can drag that right there. Again, we're creating mountains at this area, as well as might be some subduction as well. Let's keep on going. You guys are doing great. So the type of convergent plates, ocean to continent, ocean to ocean, continent to continent. So example, the Himalayas is going to be continent to continent, creating mountains. The Caribbean islands, okay, way out there, that's going to be ocean to ocean. Usually trenches are going to be ocean to continent. Oceanic crust subducts beneath continental crust, so that'd be ocean to continent. Compression causes folding of two plates. Compression is going to create mountains. Creation of mountains, again, is usually going to be continent to continent, but it can happen with ocean to ocean. Trenches and islands form. We're going to have ocean to ocean. And then trenches and volcanoes form. That's going to be ocean to continent because, there are underwater volcanoes, but a lot of volcanoes that are on land have a subducting ocean plate into a continental plate that rises up. Oceanic crust subducts beneath oceanic crust, so that's got to be ocean to ocean. All right, so just check your answers here. See what you got. Let's keep on going. Look at the picture, then answer the question below. So right now we're looking at ocean to ocean crust, okay, converging on one another. And so just make sure to talk about what kind of plate boundary is this. Well, this has got to be a convergent plate boundary, ocean. What's happening in this picture? The more dense ocean plate is subducting under the less dense one. And then what is formed as a result? We're going to get a trench here, as well as probably some underwater volcanoes that are forming where the plate is being subducted into. All right, let's keep on going. So we're looking at this picture now. We have a ocean plate going into a continental plate. Usually volcanoes are formed, like in South America. There are a ton of volcanoes all on that coast. Let's keep on going here. What kind of plate boundary is this? Well, this is going to be a convergent ocean to continental plate. Okay, what is happening in this picture? Well, there's a subduction zone where one plate is going under another one and then creating that excess lava that is created because the plate is destroyed down here in the asthenosphere, or the mantle, is going to melt and create opportunities for volcanoes to form. Okay, what is formed? Well, volcanoes are going to be formed. All right, going on to our next one, we have continental, and we're creating mountains. Okay, mountains are just as high as they are above ground as they are below ground. So when you mesh together, you're going to have a mountain go super high, both above the ground and below. So the Himalayan mountains are going to be really tall, both above ground and below ground, just a really thick part of the crust. Okay, so what's happening? This is a continent to continent convergent, going toward each other. Okay, what's happening? Making a mountain because the plates are colliding. All right, so here you're going to put in some pictures of different trenches and such, and then you're going to circle what is going on. So the Andes Mountains, Himalayan Mountains, and the trench. All right, make sure you answer these. The Andes Mountains are going to be They are in South America, and they're what I was referring to with the. Let's see if I can get this going. What I was referring to with the ocean continent, and then let's go with the Himalayan mountains, which are going to be continent. And then lastly, the Tonga Trench is going to be our last option, which is going to be ocean. Alrighty, perfect. Good job, you guys. Let's keep on going. Make sure to insert your real photos right in there. Divergent boundaries. Okay. Now our plates are going away from each other, so new crust is going to be created. You see that in this photo. So drag the green boxes correctly. Identify continent would be right here, or ocean would be right here. All right. Ocean is way more common than continent. Having a divergent boundary, it happens every once in a while, but not very often. Not very often at all. Because these things happen very, very slowly. So the last time a continent divergent boundary happened would be when we used to have Pangea, where all the continents were together and all the land masses were together as one, and then they all separated into the different continents. And so that is when you would have a continent like shift away from one another. So just keep that in mind that they're not very common. Divergent, okay, we're always going away. Let's go with continent versus ocean. So let's talk about may fill with water would be because the continents are splitting up. So water is going to fill in there most likely because there's more water than there is land. All right. And the land is a higher elevation typically. All right. East Africa Rift Valley, that's going to be continent. Mid-Atlantic Ridge would be ocean. Creates a valley-like rift, resulting in valleys and volcanoes. Let's go ocean. Process known as seafloor spreading. Ocean, because we're creating new seafloor. Okay, as they pull apart, a crack in the ocean floor appears. Yep, again, got right there. Magma fills the space between the two plates. Ocean. Nice job. All right, guys, let's keep on going. You're doing great. Only about 10 more slides to go. Look at this picture and answer the questions. What kind of plate boundary is this? Well, it is divergent. It's continent divergent. What is happening in this picture? Well, two land masses are separating, which means that water is probably going to fill in between them. As a result, what is formed? Well, two different land masses are going to be formed instead of one. We're splitting one up into two. Your Great Rift Valley, your Mid-Atlantic Ridge. Okay, your Mid-Atlantic Ridge is going to be ocean to ocean, whereas your Great Rift Valley is going to be continent. All right, make sure you find some photos of that. Let's compare and let's contrast. Okay, seafloor spreading, we got divergent boundary, usually ocean. Then we have subduction is where one goes below another one. All right, so creates new crust. They both create new crust. Well, I'm going to go with seafloor spreading because it's more of a process with subduction. Usually you're inferring that there's going to be volcanoes with the subduction, and that's why I might place that elsewhere. Destroys old crust, that would be subduction. Occurs at ocean, continental plate boundaries. Ocean, continental, yep, that'd be over here. Occurs along ocean, divergent plate. Perfect. Constantly recycling itself and renewing crust. Okay, that's going to be seafloor spreading because that is where new crust is created. Okay, happens at mid-ocean ridges. Okay, again, that's going to be seafloor spreading. Okay, gets older the farther away it gets from the ridge. Okay, again, that is going to be seafloor spreading because the ridge is going to be the middle of it. And then as that new, basically lava comes out of the earth, out of the mantle onto the crust, it is going to spread away. So the older stuff is going to be on the outside, whereas the new stuff is going to be toward the middle. All right, that's a really, really cool and pivotal part of how we discovered this. All right, results include mountain folding and volcanoes. Subduction. Okay, again, that crust is going underneath, and so the lava is being formed and then is going to come up out of it. All right, magma rises, cools, hardens, and forms mountain-like ridges. Okay, again, that's going to be subduction. And let's see, caused by convection currents from the mantle. All right, caused by convection currents from the mantle. Basically, both of these. All right, this is definitely going to be both of these. So make sure you get those answers, and let's keep on going. All right. So you're going to use the link to find the website to answer the questions below. What is a subduction zone? Where do they happen? Okay, subduction zones are going to happen when two plates meet, and they're going to happen when an ocean plate meets a continental plate, because ocean plates are more dense, therefore it's going to go below, subducting under the continental plate. Okay, and as you can see in the middle of this photo, mountains and volcanoes are going to form because this plate is going to melt in the mantle, and then there's going to be pockets of excess lava that need to escape. Okay. What happens when two tectonic plates meet? Well, a subduction zone can form, or the more dense plate's going to go beneath. Okay. What key characteristics do subduction zones have? Well, they typically are going to have mountains or volcano ranges very close to the subduction zone. Why is it important for scientists to understand subduction zones? Because volcanoes are a big deal and can be pretty dangerous. And so it's good to know where potential volcanoes will form. And by seeing a volcano, we can understand why it's there and understand, oh, there must be a plate boundary there as well. Okay, you guys are doing fantastic. Let's keep going. So now we're looking about seafloor spreading. Okay, we're having new crust form because two ocean plates are moving apart. All right, new crust is being formed. What does seafloor spreading happen? Why does seafloor spreading happen? Okay, it happens because two plates are moving away, so something needs to take its spot, and so we get brand new ocean crust. Where does seafloor spreading happen? Well, it happens at a mid-Atlantic ridge, or when two ocean plates divergent boundaries, and so they are going away from each other. What happens the farther the crust gets from the mid-ocean ridge? Well, the older it gets, the cooler it gets, and the denser it gets. Okay, keep that in mind. So cross section. All right, you're gonna find a spot for each of these. So a convergent boundary means they're coming toward one another, meaning we're looking at this ocean continental one. We're looking at a ridge. It's going to be right here. Subduction is happening because one is going underneath another plate. Okay, divergent, meaning they're going away from each other. The lithosphere is going to be this top part, whereas the asthenosphere is going to be the bottom. That's where our hot mantle is going to be warming everything up. Whew, you guys are doing great. We're going to make it. Okay, transform boundaries. We're almost done. So you're looking at this. Again, transform is going to be the sliding effect of plates. Okay, this creates earthquakes. What kind of plate boundary is transform? Where is it? What is happening in the pictures? The plates are sliding, and then what is the result? The plates are rubbing against each other, and as they rub, they're creating earthquakes because you have quick shifts in the plates, which create earthquakes. So you're going to look at two different faults, the San Andreas fault and the Alpine fault. San Andreas is in California, so it should be pretty familiar, and that's why they get a bunch of earthquakes. Thanks for surviving through this video. Have a great day, you guys. If you have any questions, make sure to attend the tutoring times or whenever we have some Zoom meetings. So have a great day. I'll see y'all later. Peace.